Alrighty, so we got another easy problem today that we're going to, I think, overcomplicate it, is kind of what my plan is going to be for this. So this is the reverse prefix of a word. What this is you're given a zero index string and a character, and you reverse the characters up to, or you reverse the word up to those characters, and then you leave the rest of the word the same. So I think they tried doing this with like actual like outfits, and I think the easier way is to see this as like an actual like word. So let's say the input was is a word prefix, the character might be an F, and what they're saying it should be is you would do F, you would get to the F and reverse everything up to this. So it'd be R F E R P, and then you would keep the IX. So you go from prefix to furpix. And you can see this is pref backwards and then IX. Um, so I think the way that I'm going to kind of think about this is actually going that same approach. So let's do I think what we can do is we can loop over the word. So let's do our typical just for int I equals 0, I less than word length, and I plus plus. And what do we want to do as we loop over this word? Well, we want to see if the word we're at is the character that is our like reverse thing. Or sorry, not I, CH. And if it is, we want to put, so let's create like a empty solution um, string. And for now, we're just going to do solution plus equals word.char at I. Heads up, we're gonna find that string appending is actually really slow. Um, and this is why a lot of times you'll use like string builder. But I've kind of I'm making an unofficial rule for myself for this one is that I don't want to use string builder. I'm gonna end up creating a bunch of private helper methods that do a lot of the typical string functionality. I think the only ones I'm saying I'm allowed to use is probably like charat and length. But we'll see for now. So what do we want to do once we get to this index? Well, we then want to like loop back on the word and reverse it. So we're gonna put the wait a second, no. We don't want to do this up. We want to start with looping and then looping back on the word and then we'll append to the solution. So let's say for int j equals I, j greater than equal to 0, and j minus minus, we're going to do solution plus equals word dot char at j. And essentially what this is saying is let's go back to our prefix with a character of f. So what we're doing is we're going P, R, E, F. We found F, and then we're doing the step of go in reverse. So what we're going to end up putting is F, E, R, P, and then continue on our first for loop. And the reason why this is going to be okay is normally you want to avoid the nested for loops. I think we're okay because at most two it's O 2 O of n, which is still O of n. I guess you have the worst case of you go, 6 letters and then you have to go 6 letters back kind of thing. So For int j, we're gonna append our word. So then what happens if we don't have the character we're looking for? Okay, what I'm gonna do is I'm gonna set up another variable called reversing. And this is gonna start off as false, and what I'm gonna do is I'm gonna set this to true whenever we find that first time we hit our true character. And to avoid all of this stuff, also my tabbing is a mess. We're gonna say if we're reversing, then we can skip all of this logic and just say solution plus equals word.char at I. And we're only, oh wait, can I find a semicolon? Jeez. We're only gonna do this if we're not reversing. And the red flag for these problems is when you start doing really dumb variables like reversing. It means you probably have a problem with your solution. I think we're gonna find that in a runtime. Like I think we're still like 2.0 of n, but we're probably gonna be like one of the worst runtimes for this O of n type problem. And then what we can return is solution.length equals 0. We'll say the word or solution. And what this is saying is if we never actually do the reversing, so we never get into a point where we hit the word, we just want to return the word itself, otherwise we return the solution. So let's see how this does. Let's get rid of our dumb code. Oh, good. I spelled reversing wrong to begin with. It becomes wrong everywhere. Ah, cool. So we passed. And let's see how bad our runtime is. Honestly, the fact that this did better than 5% is a bit of a concern. Um, so let's think of some ways that we could potentially make this better. And I think my main concern right now is how we're doing the reversing logic. And what I'm gonna start is rethinking this use of a reversing character, which means you have to get rid of this logic. And you know what? I'm gonna propose that we make private helper methods for everything that's like essentially built-in functionality. And we'll do a lot of that easiness by casting it to an array. All right. So here's what I'm kind of thinking is let's start, we'll even make a helper method that casts it to an array. So we'll say chars equals, so normally you can do like word.toChar array, but we're gonna be fancy and make our own. So how would you make a char array? And it's gonna be returning a char array. It's called to char array, and it's gonna take a string of our word. And what we can do is first allocate space for our response equal to the length of our word. Char array chars is equal to a new char of length word dot length, and then what we can do is just do a for loop that does our normal just iteration. And in there, we're gonna say our allocated array, that ith index is just gonna be the word char at I. I can type, I swear. And at the end, we're gonna return chars. So here's our little helper method for how you can cast our chars away. Honestly, I really like doing this kind of method on these kind of submissions because I forget all these little helper methods all the time. And honestly, what happens whenever I put stuff in code review is I'll make a dumb private helper method like this, and someone will just be like, bruh, it already exists. Okay, so we're gonna do a char away of um, our initial word. Let's also, we're gonna also want to get the index of where we have the first presence of that character. So let's say int index equals, and again, there's already an index of method, but we're gonna build that from scratch because again, this is an easy problem. Let's make it hard. And this is gonna take the chars and the character. And if we go down here, let's make our private index of method. And this is also, we can eventually call that reverse array method that I have down there because we're going to need this to help find our indexes. But we have char array and a character ch. Then what we'll do, how do we want to do this? Well, we can loop over. Helps if you have a variable to do stuff on. So we're gonna loop over the cars, the cares, whatever you want to call it. And we'll say if the character we're at is equal to the character we're looking for, then we return I, and otherwise we'll return -1. And what this is saying is -1 is just if we never find the character in our index, then that means we can just return like the word as it is. So we have index of the character where we want. So if index is not -1, we're gonna do our stuff. And if it is, we're just gonna return word. And in here, we're gonna do the actual processing of our our word. And really, all this is gonna be is we're going to call that what I started making, which is this reverse array of the characters from 0 to the index. So what this is saying is we're going to have a method that takes our character array and everything from the 0th to our index, we're going to flip-flop. And then everything else would stay the same. And after this, we can just return a new string with the cars. And now this is dependent on us making this reverse array. Oh, a new Amazon deal. All right, so let's figure out how this reverse array method is going to work. So, two-pointer start, what we're saying is we have the 0 and the ith index. And what we're gonna say is while start is less than end. And then we're gonna essentially we're going from the two sides and we're working our way in. Oh, I already have that parenthesis. Do I? Why are my parentheses all off? There's gonna be some compilers somewhere. I don't know why, but it's not happy with me for some reason. We'll figure it out. We're gonna have a temp character, which is gonna be the start of our character array. Then we're gonna put the end into our start spot, and then in the end spot, we're gonna put that temp. And then for each of these, we're going to iterate start over and end over. And let's just talk through this real quick, what's going on. So let's say we have an array that's like 1, 0, 1, or 1, 1, 2, 3. So, and we're going from 0 to the second index. So we're going to say that 1 is our start, 1 becomes our temp. So temp is 1. We're going to swap this place to 3. And then we're going to take that temp that we held and put it into 1. And then we iterate both ways. At this one point, it's done, but you can kind of imagine how that's going to keep going on. And as you keep going further and further in, so you start with, you might have 0 and 4 get swapped. Then you would have 1 and 3 get swapped. And then you have 2, 2, and the condition's no longer met. And you can see that we keep moving in with what we're flipping. And eventually, like, it's kind of mathematically works where if it's an even number, then you swap 2 and 2. If it's odd, you swap 1 and then you have like start equals end, so you're no longer in the while loop. And at this point, so what we have done is we have everything in the word reversed. It, just the parts of the array though that are between start and end. And where this is kind of relevant is let's say we have our prefix example, and we're going to from 0 to 4. So that's going to be, or 0 to 3, right, for the RF, example. Well, so with our swap, the order is going to be 3, 2, 1, 0. But then we still have indexes 4 and 5 in place. So 3 is F, 2 is E, 1 is R, 0 is P, and then the I and the X are still in the same spots. So we're keeping the character array exactly the way it is outside of the start and the end parts that we're reversing. And then at the end, where is it? We're just returning that as a string. And let's make sure this compiles. I'm pretty sure we're not, because we were having problems with uh, with brackets, which is never a good sign. Alright, so why is it yelling about this Charlie method? Character I is equal to word char I. Why does it think there should be a bracket here? Oh, because this should be cars. Chars. Chars, cars, same thing. Alright, so index of is also getting yelled at. What do we have wrong here? So, private index of, and it's yelling about 30. Oh, because I didn't return an int. Syntax is fine, I swear. And now it doesn't like this method. Let's see if I can fix my parentheses finally. Or is that rooted? That's rooted in all of this as well. Private void, reverse array, character array, int start, int end. What doesn't it like with this? Well, that's fine. Do I like random character? Oh, I thought that was like a piece of dirt on my screen. Oh, that's funny. This is why you clean your monitors. Makes you code better, I swear. All right, so I feel pretty good about this. Ah, still something. Yeah. Oh, we have to get rid of our code that we don't like anymore. So we essentially said all this was bad. Unfortunate, but sometimes you write code and it doesn't get used. Get used to it. Cool. Ah, there we go. So we got our time good. Why is our space so bad? Huh. So there's something we should be able to do to make our space efficiency better. Oh, you know what we could probably do? Is we could probably make this reusable because we don't actually need it in that many spots. So let's create a private character array chars. And then here we just say chars is equal to the to char array. But we can then reuse this same one down in our char array. And we can say instead of this first line, we'll say if null or word dot line. Then new array word dot line. Essentially, what we're saying here is if the our private field is null or we need to like allocate more space for it, then let redo that. Otherwise, leave it as is. And this makes it so we can reuse the memory space from before. And let's just make sure the rest of that method makes sense. Think so. Let's check that. Where are we off? If class expected. Let me think this over. Why is it not recognizing my chars here? Oh, it's not yelling about that. It's yelling about this not being charged that lane. Cool. And this should save a little bit of memory for us, and it's probably enough to, yeah, you can see we got into the a better spot with memory. Um, did we? What was it before? I forget. Um, oh well. I think we got from like 60 something to a little bit better. I wonder if there's anything else we can do to make our memory a little bit better. Memory is actually like a really interesting problem to be solving now because I feel like everyone focuses on the runtime, and the idea is you should also minimize your memory as you get you should minimize your memory for the minimum runtime. Because memory is starting to become a bigger problem, especially in a lot of like data visualization stuff or like gaming stuff. Oh, we need to fix this. So we should make it so we do just zero in index and then take create a substring directly from our array and allocate it here. And then we need to update our reverse arrays so that it uses um, the original one. And what this is going to be is char temp is now chars, chars, chars. And let's make it so we also don't allocate an extra array here. 41.6, so we got down a little bit more, right? Or did we actually get worse? How much does our memory change? Okay, we're fine. I might be just playing with some. Anyways, the whole idea here is I'm trying to make it so that we don't create an extra array anywhere for an unnecessary reason. But I don't know. At that point, that's kind of the theme is just overkilling an easy problem to make it fun. But hope you learned something in this one. This is what's it called? Reverse prefix a word. See ya.